Our last lesson for the whole year is on how to estimate limits algebraically. So we talked a lot yesterday, or the last lesson, about evaluating through graphs and tables, and we kind of alluded to the algebra, and we're going to really focus on the algebra today, because a lot of what's on your final can be done just strictly through algebra. But you have the option to still look at the graph, that's fine. Finding limits at a point. If you know your function is continuous, then you're just going to directly substitute in the value. It's not really a big mystery. There's a bunch of properties of limits you're going to discuss in calc. We're going to kind of skip over these, frankly, for pre-calc. But look at this question. We have a parabola, a continuous polynomial, and they wanted to know what happens when x approaches 4. Well, forget the what's around 4 business. Just plug in 4. So when you plug in a 4, directly substitute it, you get -5, and that's the answer to the limit. Had you gone to the table and plugged in -5.001 and -4.999, you would have seen that they were approaching, oh, I'm sorry, I had the wrong number. If you were approaching 4.001 and 3.999, you would have seen that the function was also approaching -5. So if you know there are no discontinuities and you can just directly substitute, please do. So direct substitution for polynomials, check. Rational functions are a little exciting. You have to be careful. Sometimes you can just plug them in, and sometimes that's where the asymptote or the hole is existing. So in this case, you want to think about how you could remove the discontinuity if possible, and then if it's an infinite limit, we'll talk more about end behavior questions. So I always look to directly substitute first. That's my rule. So here we have a polynomial. There will be no discontinuities in a polynomial, so just plug in -2, and I think that's already done for me on my notes. You guys can plug in numbers with the best of them. Just watch your parentheses. Make sure that the -2 to the 4th power, you're only taking -2 to the 4th power in parentheses and all that jazz. Alright. So here we have another polynomial, so just plug in a 3. So 2 times 3 squared minus 5 times 3, let's see, 18 minus 15 is 3. This is not a polynomial, but it's not going to be undefined when I plug in a 5, so let's just plug in a 5. So 5 to the 3rd power minus 4, hello, is 125 minus 4, so this is the square root of 121, which is an 11. You could use your calculator, could use your graph, could use your table, whatever you want. Now let's talk about infinite limits. So when we have a rational function, oh, I'm sorry, not yet, jumping the gun here. When we have a rational function, we have to watch out for discontinuities of various types. Sometimes they're asymptotes and sometimes they are holes. If it's a hole, remember it's called a removable discontinuity because you could literally remove it from the problem. So here's an example of they factored x squared minus x minus 20 into its form, x minus 5 times x plus 4, and then they removed the discontinuity by canceling these terms out. So all they were left with was x minus 5. That's the resulting line that's graphed, but remember there's like a weird hole in it at x equals -4. But now you can take that limit and directly substitute -4 into this non-removed part of the function. So -4 minus 5 is -9. The example you see on your notes is not the same, so be careful. X minus 5 times x minus 4 is how you factor the numerator, and then we're going to remove that discontinuity. So now you can just directly substitute a 4 in there. 4 minus 5 is -1. So that's kind of nice. You don't have to depend on your table and your graphing. So this one, direct substitution, is not going to work because -2 plus 2 will be a divide by 0. So we have one of those removable discontinuities. Let's factor x plus 7 times x plus 2 over x plus 2. So we remove the discontinuity, and then we can evaluate the limit as x approaches -2 of this resulting function, which is x plus 7. So plug in a -2. -2 plus 7 is 5. So that's nice. I like not having to depend on my calculator for every single question. What else we got here? So this one, plug in a -4. Not going to be a problem anywhere. So this is -1/4 plus -4. So how about -4.25? It's a good answer. I like it. All right, moving along. Polynomial, just plug it in. Just be careful with parentheses, please. So we have negative and then a 2 squared. You're not squaring the negative coefficient. Plus 5 times 2 minus 1. So what? -4 plus 10 minus 1 is 5. I can't see that. Let's move. There we go. Cannot just directly plug in a 0 because that'll be undefined. So let's kind of mess around with this numerator. If I expand 3 plus x squared out, that's x squared plus 6x plus 9. And then you still had a minus 9 right here. So, okay, I see what's going to happen here. The 9's are going to cancel. And then this remaining part can factor. You can take an x out of it. So it's x times x plus 6 over x. And now I can remove the discontinuity. Boom. So we're going to find the limit as x approaches 0 of the new function x plus 6. So let's just directly plug in a 0. The answer is 6. Good, good. All right, so infinity. It's just end behavior. We kind of alluded to this in the last lesson. So let's take a look. Remember your rules about end behavior? They're all listed in this chart, but they're a little confusing, so I just use my old knowledge and mentally think about the graph and then I sketch it. So we have a polynomial that's odd degree, positive coefficient, so the ends kind of do this, right? Whatever happens in the middle, I don't really care. I want to know what happens on your left side. On the left side, it's going down. So the way we say that is it approaches negative infinity. You don't really need the approaches arrow. I like to use it for limits because then I know what I'm verbally trying to say to the reader, because this can get a little confusing. All right, so we already did that question. Moving on. All right, here, Mrs. Hoffbauer is a saint and she gave me all this graphing stuff, but I'm just going to think. This is a rational function that's even weight, and the rule for end behavior for even weight rational functions is you look at the coefficients. So you have a horizontal asymptote, the end behavior, of y equals the coefficients, which is a 1/4. So on either side, positive or negative infinity, it's going to flatten out at 1/4. So x approaches negative infinity, that means my function is going to be approaching 1/4. What we got on our calculator also says 1/4, but you have to remember what 0.25 means. All right. Plugging, okay, these are the end behavior rules for bottom heavy, basically. So if you have a huge number going into a denominator of a fraction, what that does is it divides by something gigantic, and the number gets smaller and smaller and smaller. Sometimes it's negative, but it's really, really tiny. It's approaching 0. So that's why bottom heavy is always coming out to approaching 0, or the end behavior function of y equals 0. That was for bottom heavy rationals. So here we have an odd degree polynomial with a negative coefficient. So instead of the left end going down, the left end's not going to be going up. It's going to do something like this. So on the left side, which is what they want, your function is approaching positive infinity. You don't need the plus sign if you just write infinity. I know what you mean. Okay, we have a rational here, and it is bottom heavy. So plugging in something gigantic down here is just going to make this guy flatten out at 0. So your limit is that it approaches 0. All right, equal weight, rational. So we're supposed to look at the coefficients, and there would have been a horizontal asymptote at 6/10, better known as 3/5. That's also the limit as x approaches infinity. So we are approaching 3/5. Polynomial, odd degree, so the ends go like this. This time they want the left side again. On the left side it's going down, so approaches negative infinity. These are like my favorite questions because they're so easy. All right, we got bottom heavy. So bottom heavy rational has a horizontal asymptote at y equals 0, which means it flattens out at 0 for the end behaviors. So that's what we have for our answer. Limit approaches in 0. 0. Polynomial, this time we have positive coefficient with an even degree. So the ends are going to both go up, up. So on the right end, it's approaching positive infinity. There we go. Again, all of this can be confirmed on your calculator. You don't have to remember the rules, but man, this goes really fast if you know your rules. All right, rational function, it is even weight. So we're going to look at the coefficients. There would have been a horizontal asymptote at 1/2, which happens to be my limit when x gets really big. So this function is approaching 1/2. Again, confirm on the graph if you need to. The table's a little easier for confirming that one, though, I will tell you. This is kind of a cool question. So, Tamika takes 2 milligrams of asthma medicine, and she takes it every day. So, if you think about like medicine in your body, it dissipates its effectiveness throughout the day, and it depends on what kind of medicine it is, but it tapers off, and then you get a new dosage and keeps tapering off. So, find the limit when it approaches 3 from the left side. So, before the 3rd day hits, well, the milligrams in her body are closer here to 2, right? And then on the other side of 3, it's up here because she just entered a new dosage into her body. She breathed it in probably. So that makes sense. At day 3, like the minute she wakes up on day 3, she's going to have 2 milligrams in her body, but then she's going to go take her medicine and then it jumps up to 4. So as far as one-sided limit there, we're not going to be able to answer that because that's a weird question to ask. But that's a good application of medicine. All right. These are, I think it's another case where it's on your worksheet. It's also from, actually it's just on your worksheet, and they're really legible, so I'm not going to do your homework for you. Good luck. Ruza signing off. That's our last lesson.